Now we have an example of a third order equation, still linear with constant coefficients and non-homogeneous. So first of all, we solve the associated homogeneous equation. Y triple prime minus y double prime minus 4y prime plus 4y equals 0. The corresponding cubic equation, algebraic equation, is lambda cubed minus lambda squared minus 4 lambda plus 4 equals 0. I can do partial factoring between these two. I can take out a lambda squared, and therefore we'll be left with lambda minus 1. And now from these two, I can take a minus 4. So that from the first term I have a lambda, and from the second term I have a negative 1. And now I can factor a lambda minus 1. And we'll obtain lambda squared minus 4 equals 0. So my solutions are going to be lambda 1 equals 1, and then from lambda squared equals 4, a second solution equal to 2, and a third solution equal to minus 2. So we have three distinct real solutions, and therefore the general solution of the homogeneous equation is given by y of x equals c1 e to the x plus c2 e to the 2x plus c3 e to the minus 2x, where c1, c2, and c3 are real numbers. Okay, this was the past. Now the new part is finding a particular solution. Okay, so we have again here the sum of two types of functions. One is a constant, which is a polynomial of degree 0, and the other is an exponential, e to the x. So in general, I would look for a polynomial of degree 0, which is simply a constant, a, and then plus, for the exponential, a constant, b times e to the x. Now let's check if we can already determine if this is going to be successful or if we need to multiply anything by x. First, for the constant, we see that constant, just a constant like c, is not a solution of the homogeneous equation. Also, this is because lambda equals 0 is not a root. So this constant a will work just fine. But the exponential will not work because we can see that we do have this term, constant times e to the x, which we already know to solve the homogeneous equation. So if we were to plug that into the equation, we will get 0 and not minus e to the x. We also notice that this corresponds to lambda 1 equals 1, which only appears once. And in fact, here we do not have e to the x times x as a solution of the homogeneous equation, which means it will be enough to multiply this term by x. And now we can proceed and check if this actually works. So this is supposed to be dealing with the yellow minus e to the x part, and this is for the constant 5. Now let's see, take derivatives. The first derivative is just 0 plus b e to the x times x plus b e to the x. Here we have to use a product rule. Let me factor b e to the x to simplify the following computations. So times x plus 1. And now the second derivative will be b e to the x times x plus 1 plus product rule b e to the x times 1, which we can simplify to b e to the x This term gives us x plus 1, this gives us another plus 1, so this is x plus 2. And then I also have to do the third derivative because this is a third order equation. So again, by product rule, b e to the x times x plus 2 plus b e to the x times 1, which I can factor this b e to the x. The first term gives me x plus 2, the second term gives me plus 1, so ultimately x plus 3. And now I'm ready to plug into the equation. So let's remove this and just keep the general solution of the homogeneous equation. So the equation is y triple prime, so this one, b e to the x times x plus 3 minus y double prime, so minus b e to the x times x plus 2 minus 4y prime, so minus 4 times b e to the x times x plus 1 plus 4y, so plus 4 now here I would open a parenthesis, but let me distribute right away, so 4a and plus 4b e to the x times x. All of this should equal 5 minus e to the x. So let's group together the terms with e to the x. So let me factor from these terms b e to the x. Okay, the first one gives me an x plus 3. The second one gives me a minus x plus 2, so distributing minus x minus 2. This one gives me a minus 4 that multiplies x plus 1, so minus 4x minus 4. And the last one simply gives me plus 4x. Then we have the plus 4a, and this should be equal to 5 minus e to the x. So if we did it right, these terms with x here should disappear because I only have e to the x here. But indeed this is true. X and minus x cancel, minus 4x and plus 4x cancel, and I am left with 3 minus 2, which is 1, minus 4, which is minus 3. So minus 3b e to the x plus 4a equals 5 minus e to the x. And at this point, I have the constant term, which should be equal to this one for a, and the exponential term, e to the x. Here it has a coefficient of 1, and here it has a coefficient of minus 3b. This allows me to find a system of two equations in two unknowns and find a and b. So let's erase these previous computations. And actually all of this, you can pause the video if you need to look at them. But we obtain that 4a must be equal to 5 and minus 3b must be equal to minus 1. So a is 5 over 4 and b is 1/3, meaning that my particular solution is a, which is 5 over 4, yes, plus b, so plus 1/3 e to the x times x. And then the general solution of the non-homogeneous equation, is given by the sum. So let's just copy this. Plus the particular solution.